Welcome. It's been almost 35 years since PBS premiered one of its most successful series of all time, Carl Sagan's Cosmos. Many of you may remember, as I do, his elegant exposition of the universe.
Some part of our being knows this is where we came from. We long to return. And we can, because the cosmos is also within us. We're made of star stuff. We are a way for the cosmos to know itself.
Over 600 million people in more than 60 countries have now watched Cosmos. But in the decades since, the universe has kept moving, literally, moving in every direction, and so has science. And that's why Cosmos is returning this spring, this time on National Geographic Channel and Fox TV.
It's time to get going again.
Our guide is the astrophysicist Neil deGrasse Tyson, America's most popular scientist, the unabashed defender of knowledge over superstition, and clearly the rightful heir to Carl Sagan's curiosity and charisma. So, fasten your seatbelt for a whole new interstellar journey through tens of millions of years and hundreds of millions of miles to the farthest reaches of outer space. Neil deGrasse Tyson is the Frederick P. Rose Director of the Hayden Planetarium at the American Museum of Natural History here in New York, where he narrates a breathtaking new show titled Dark Universe. I took my 12-year-old grandson to see it over the holidays, and we were mesmerized. Imagine trillions of stars, 100 billion galaxies, and light traveling 100 million years before reaching us here on Earth. That very planetarium, by the way, is where Neil deGrasse Tyson, a kid from the Bronx, age 9, first felt the universe subpoena him to become a scientist enthralled to the night sky. He's written 10 books, including this memoir, The Sky is Not the Limit, and this, his most recent, Space Chronicles, Facing the Ultimate Frontier. Oh yes, I almost forgot. People magazine once voted him the sexiest astrophysicist alive. Welcome.
That was a few years ago, actually.
You only got it once.
I know.
No bragging rights, right? But you clearly got more of the star stuff that Carl Sagan said we're all made of. You just got more of it than we did.
Well, yeah, I've been touched by the stars, perhaps more frequently than others.
But you were just 9?
9 years old. A family trip. My parents, we were all native New Yorkers, and my parents knew well the value of all of the cultural institutions of New York City. We went every weekend to one or another of these institutions, if not the zoo, the art museum, the many art museums, the Hall of Science, and a first visit to the Hayden Planetarium for me. By the way, I would ultimately go as a school trip, but for family, I go there and I sit back, and I'm certain, I love the word you said, I was subpoenaed by the universe. I think I had no choice in the matter. I think the universe called me. Because when the lights dimmed and the stars came out when I was 9, I'd never seen a sky like that in my life.
And you met Carl Sagan at 17 when you headed to Cornell?
Yeah, well, so I applied to colleges knowing full well that I was interested in the universe. My application to Cornell, unknown to me, was forwarded to Carl Sagan. He was a professor of astronomy there. And I was deciding what college to go to. He sent me a personal letter. Man, I'm just a 17. He was already been on The Tonight Show and had best-selling books. Here's a personal letter said, I understand you're considering Cornell, and you're like the universe, as do I. So why don't you come by? I can give you a tour to help you decide whether this is where you'll ultimately attend. So I went up there. He met me outside the astronomy building and gave me a tour of the lab. One of my favorite memories is he reaches back, didn't even look, just reached back, pulled out one of the books that he wrote, and then signed it to me, and I said, that is awesome. And I said to myself, if I'm ever in a position of influence the way he is, then I will surely interact with students the way he has interacted with me as a priority.
Do you remember seeing Cosmos when it first aired?
Yeah, but by then I was in graduate school, so it didn't influence me the way it influenced others because I was already established. But what it did tell me was that there was an appetite out there for for science, if it's delivered in a way that's compelling and that's warm, that's compassionate, that is as though the person who is bringing the science to you is sitting next to you on the living room couch. And I thought that bedside manner is something that more science expositors should be doing. And I've used it kind of as a model for me going forward.
So what are we going to learn about the universe from your cosmos that Carl Sagan couldn't have known about? But let me put it this way. If Sagan were around to see your series, what would he learn about the universe that was unknowable 30-some-odd years ago?
Yeah, so that's a good question. So you need to think of Cosmos not as a documentary about science. By the way, since then, there have been many documentaries about science. And it's quite a fertile way of delivering the viewer to the frontier, or bringing the frontier to the viewer. So that's not the issue here, because we all remember Cosmos, and so many of these other documentaries maybe live their moment, but then they fade. Why did Cosmos not fade? It's not because it brought you the latest science, although it also did that. It's because it displayed for you why science matters, why science is an enterprise that should be cherished as an activity of the free human mind, because it transforms who we are, how we live, and it gives us an understanding of our place in the universe. And it's these states of mind that you carry with you for the rest of your life. So in the new Cosmos, that we are continuing this voyage, we're continuing this epic exploration of our place in the universe. We have other stories to tell beyond the ones that went on back then. Yes, right now we are steeped in the ignorance of dark matter and dark energy. And at the time of the original series, there were no known planets outside of those orbiting the sun. We suspected they were there, but right now we're rising through 1,000 planets, happily orbiting stars that are not the sun. So these are not, that's not simply new science, it's new vistas of thought and imagination.
That place in the universe you talk about, as you know, scares some people. Someone once told Sagan that they didn't like astronomy because it made them feel small and insignificant in comparison with the grandeur of the universe. It clearly didn't affect you that way.
Well, it depends on what your ego is going into the conversation. If your ego starts out, I am important, I am big, I am special, you're in for some disappointments when you look around at what we've discovered about the universe. No, you're not big. No, you're not. You're small in time and in space, and you have this frail vessel called the human body that's limited on Earth. If you have no ego, if you just want to explore the world, look what happens. Here's the conversation goes differently. You learn, oh, the molecules and the atoms of those molecules in my body are traceable to stars across the galaxy that have lived their lives, manufactured these elements, exploded them into the universe, from which new generations of star systems were formed. So I look up at the night sky, I don't feel small, I feel large. I feel connected to the universe. It's not just we here on Earth, and that's there. We are one. And that link, for me, is one of the most profound discoveries of modern astrophysics. And if that should not make you feel small, that should make you feel large.
At your planetarium show, which I went to the other day, just over the holidays, I did feel small sitting there looking up at 100 million light years coming at us. But I also felt significant. The very fact that my grandson and I are here in this universe together is not insignificant.
Not only that, it's the human mind applying known laws of physics to the universe allows us to even come with an understanding of what's going on out there.
Have we figured out our galaxy?
So, yes and no. All right. So the yes part is we've got some laws of gravity and optics and motion, and yeah, we can use our knowledge of physics and our knowledge of the frontier of science to land a probe on Mars within a few meters of the target spot. This is tens of millions of miles away, right? There is no golf shot It's that accurate, all right? Not even a hole-in-one is as accurate as what this shot is. So what we do know that has been tested works. And that's quite a state of empowerment. But there's a saying where as your area of knowledge grows, so too does your perimeter of ignorance. Because this is the boundary between what you know and what you do not know outside of that area. So we didn't even know to ask, why is the universe accelerating against the efforts of gravity? Until we made the measurement that it was so. So before 1998, we couldn't even ask the question. We didn't even know to ask the question. So there's no sign that everything will ever be fully known, because this moving frontier continues to bring us more questions. So can we measure how ignorant we are? Perhaps. We know that what we do know about the universe comprises 4% of everything that drives it. 96% of what's driving this universe in the form of dark matter and dark energy, we have no idea.
How do you know that it's 4%? Because you haven't been able, have you, to measure what we don't know?
No, so that's a really cool question. In science, in astrophysics in particular, in all sciences, you have the capacity to measure something, even if you don't know what it is.
How so?
Well, so, for example, you could measure the fact that something is falling to the ground, but not know what it is or what's causing it or why. But you can measure it. You can measure the sun moving across the sky, build calendars based on that, and not even know that Earth goes around the sun. You can, and once you find out Earth goes around the sun, that flips your point of view, but it doesn't invalidate the concept of a year. You can make all manner of measurements and not know what's causing it. We measure this thing we're calling dark matter. We measure this phenomenon, dark energy, that's forcing the universe to accelerate. When you add up what we know with those two things about which we don't know what's driving them, we only know 4% of what's driving them. So that's humbling. Yeah. That's humble. The humblest person in this world is the astrophysicist, because we are face to face with our ignorance every single day.
But here's what puzzles me, among other things, about you astrophysicists. I mean, the magnitude.
That's why you say that. You astrophysicists.
Yeah, well,
you guys.
Yeah, you guys. You're dealing, as I saw in your planetarium show, you're dealing with trillions of stars, 100 million or more galaxies. How do you even imagine? How do you comprehend? How do you get your mind around, to use the cliche, numbers of such magnitude?
We start early, and I was start them early. Think big early. In fact, calculus as a branch of mathematics embraces the infinite. You sum an infinite series of numbers or expressions. You start thinking about large things early, or a large enumeration of objects early. The way I like to think of it is you can give analogies. So one of my favorites, do you remember when McDonald's actually kept count of how many hamburgers they sold?
Like the national day.
Exactly, there it was. And they had an interesting sort of their own version of a Y2K problem, because when they got to 99, there was not a slot for a third place. So there was no room enough to put 100. So many of them just got stuck at 99 billion. So I did the calculation for 100 billion hamburgers. If you laid them end to end, you could go around the Earth like 32 times. Around the Earth, end to end. And then with what's left over, after you've done that, you can stack them to the moon and back with your 100 billion hamburgers. And that's about how many stars there are in the universe.
How much Pepto-Bismol would you need to deal with that?
Didn't do the Pepto-Bismol calculation. So it's fun to think of large numbers in these other contexts. And of course, there are numbers larger than anything that's enumeratable in the universe. The number of Google, back when Google was only a number and not also a corporation, Google is a 1 followed by 100 zeros. That number is larger than the count of particles in the observable universe. So there's nothing in the universe that you can count that will add up to a Google. So what I did as a kid, you just have fun with numbers. And so when big numbers show up in the universe, I say, yeah, give me more. And what worries me is that when the debt goes to $1 trillion or possibly $250 billion, the national debt, It's never a quadrillion. But when it gets there, do people really know how big that is? I don't think so.
They don't.
So we're handicapped by not knowing and not being able to think creatively about how large these numbers are.
I think you make me realize what I was experiencing there in the planetarium. When you started, you said we're not going to focus on what we can see, stars and planets, moons and nebulae. We're going to focus on what we can't see. And it is.
Dark matter. That's the audacity of the show. I don't know any other show that said we're going to make as the topic, as the central theme, something about which we know hardly anything. And that was not only a scripting challenge. The writer here was Timothy Ferris. I'm a fan of his work from way back. And so there's a scripting challenge. There's a visualization challenge. Our director of astrovisualization, which is a really cool title, if you ever want one, I think, is Carter Emart. These are people, he's a scientifically literate artist, a visualizer. And so you bring this, and others, you bring this talent together. You say, here's something we don't know what it is, but it affects other things. Let's see how the rest of what we know can proxy for that which we do not know. By the way, this is how we know a black hole is out there. You can't see a black hole, but you see what effect a black hole has on everything. It wreaks havoc on its environment. So dark things have a way of manifesting themselves.
Dark money as well. Dark energy, dark matter. Mm-hmm. How do they differ?
Well, unfortunately, they have similar sounding names, and since we really don't know what either of them is, I don't think we should have named them. That we should have given them fake names until we understood them. I've been voting for like Fred and Wilma, something that doesn't give you any cosmic bias. All right, so I can tell you simply what dark matter is. But don't think of it as matter. I don't want to. I'm concerned.
Like this table.
We don't know what it is, so I don't even want to use those two words. If anything, it's dark gravity, because we look in the universe and we see the effects of gravity, and let's add up all the stars and galaxies and planets and comets and black holes, everything we know about, to account for this gravity that we see. We account for 1/6 of the forces of gravity we see in the universe. There is no known objects accounting for most of the effect of gravity in the universe. Something is making stuff move that is not anything we have ever touched.
And that's something you call, for lack of a better term,
dark matter. But that even implies it's matter. What it truly is dark gravity. Boom. That's a problem that's been around since the 1930s. It's the longest standing unsolved problem in astrophysics. So now, dark energy. We look out in the universe and we expect to see the universe. Our universe is expanding. We've known this since Hubble, the man, Hubble. There was a man called Hubble before he became a telescope back in the 1920s. And when Hubble, he discovered not only that our galaxy is one of many, he discovered that galaxies are scattering apart from one another. This was the expanding universe in 1929. So when you reveal this, you say, okay, if we've been doing this for a while, all those galaxies are going to feel each other, and they're going to ultimately want to slow us down in this expansion. So you go out to measure that. And that act led to a measurement that no one believed. That, initially, that the universe is accelerating. It's not slowing down, it's speeding up. These measurements were made back in the 1990s. A Nobel Prize has now been awarded for this discovery, just recently, a couple of years ago. The discovery papers were in 1998. So we don't know what's going on. Some mysterious pressure in the vacuum of space acting opposite the force of gravity. We don't know what it is, but we can measure its effect.
So you measure it by measuring its impact on something else.
Precisely.
It's
an impact on the 4% that we can measure.
So it's the pressure that's expanding the universe?
Something, I'd use the word pressure. Something is making the universe accelerate again. We know why we had a Big Bang. Big Bang put everything into motion. I'm good with that. We're good. It's like me tossing a ball up into the air. It's moving upward even though it's slowing down. Okay? Gravity is slowing down that upward motion. We expected gravity to be slowing down the expanding universe. The opposite is happening. We don't know what's causing it.
What is the practical difference it makes whether or not we find out what dark matter and dark energy are.
If you were around in 1920, maybe you would have been saying, what's the practical difference of measuring the behavior of atomic nuclei or atoms themselves? We can't see atoms. Why do I care? This is just wood. This is a wood table. I'm in a leather chair. I'm good to go. Why are you investing so much energy, so much brain energy on understanding what's in the middle of an atom? That seems like a waste of this brilliance. In the 1920s, in addition to discovering we're not the only galaxy in the universe and that the universe is expanding, that's a watershed decade, because in that decade, quantum physics was discovered. And perhaps if you were around asking me that similar question then, you'd have questioned the whole enterprise. Yet today, a third of the GDP of the world is generated on the creation, storage, and retrieval of information. And the entire IT revolution cannot exist without an understanding of what's going on inside the atom. It is a quantum physics phenomenon. So you ask me, I have no idea what value it is. Come back in 50 years, we'll have this conversation, and you pull up the tape, and I will show you asking me what value is the knowledge of how that works.
One thing I took away from your planetarium show is that dark energy, as you just said, is responsible for the increasing rate at which the universe is pulling itself apart, right?
Yes, so I'd rather word that differently. I would say the universe is accelerating. We call that dark energy. So you're saying dark energy is responsible for that. There's something, whatever it is, we call it dark energy. That's our placeholder term to describe what we observe, the acceleration of the universe.
Well, I'm glad you explained that, because
By the way, there's nothing known will stop this. So there's been some concern that maybe space does not have the flexibility necessary to allow such rapid expansion. And might space tear in some way previously unimagined? And what does that even mean? Does the question even have validity?
You mean the House of Representatives cannot pass an act that will stop this, as they would like to? No, seriously, I was going to ask you, because if the universe, that term, if that phrase, if the universe is pulling itself apart, does it ultimately disintegrate? Does it ultimately collapse?
No, there's no evidence to say that we will ever recycle ourselves. All evidence points that we're on a one-way trip to oblivion. So the universe expands, the temperature of the universe drops, all stars eventually will run out of fuel, so the stars, one by one, in the night sky will turn off. And in the extremely distant future, a quadrillion years into the future, there'll be no light coming to us in the day or night sky. And because all stars would have died, and all gas clouds would have made stars that were going to make them, and there'd be no more new stars created. And so that the universe will end not with a bang, but with a whimper. And not in fire, but in ice.
But don't worry, we will not leave you out in the cold. We'll be back, in fact, next time with Neil deGrasse Tyson to talk about whether scientists are discovering God in the dark matter that holds the universe together, even as it hurtles ever outward from us. And in the meantime, there's much more at our website, BillMoyers.com. I'll see you there, and I'll see you here next time.